Okay, now the second video of section 1.7 is going to be dealing with that A term that's in front. It's called a non-rigid transformation because the shape does not remain intact. It gets either skinnier or fatter. So that's why it's referred to as a non-rigid transformation. Okay, so basically what we're going to be keeping an eye on is just this A term in front. Okay, it makes the graph skinnier or fatter. Alright, now I'm not real picky about how skinny or how fat the graph is, with the one exception, and that is where does it fit with respect to the 1, 1 points. We talked a little bit about the 1, 1 points last section, but let me remind you here. This is our x squared graph. And if you notice, the graph goes through the 1, 1 point right here and right here. The next is our x cubed graph. It also has 1, 1 points. The square root graph goes through that 1, 1 point. The absolute value graph goes through that 1, 1 point. And also our reciprocal functions go through the 1, 1 points. Okay, that's how we're going to determine skinny or fat. Where does it fit with respect to those 1, 1 points? If the A value, and I want you to ignore the sign does something different, okay? So in the book, what they'll do to get around this rule is they'll put absolute values around that, okay? Just to let you know that ignoring the sign, if you ignore the sign, if A is less than 1, then the graph is fat, which means it goes outside the 1, 1 points. If that A is greater than 1, that means it's skinny. Now let me kind of explain to you why this is. If you think about this function, and that's, I don't want you to think about this one yet. Just think about, I'll just put f of x. Okay? If that is your standard function, what happens to that graph if I put a 3 in front of it? Okay, basically it's saying that y is going up 3 times faster than the original function. Okay, and if it's a 1/2, that's saying that y is going up half as fast as the original function. Okay, that's kind of why these transformations work the way they do. So let's take a look at that y equals 3x squared. Okay, it's obviously greater than 1, so that means it's going to be skinny, which means it's going to be inside of those 1, 1 points. Alright, now if you want to be more specific on your graph, okay, that basically means that it goes up 3 instead of 1. Okay, instead of being at 1, 1, it goes over 1 up 3. Okay, and so that green function is the new function. That is 3x squared. And here's what I'm looking at. Right here and here. Those lines are inside the 1, 1 points. Alright, let's try another example. Y equals 1/2 x squared. Okay, 1/2 is less than 1, so this graph would have to be fat. Fat means that it's outside the 1, 1 point. Specifically up 1/2 instead of 1. Okay, so if you notice, instead of going through the 1, 1 point there, it only went through at half. And that's how you become a little more specific when it comes to the skinny or the fat graphs. Alright, That is the end of this video. Reflections is the next one. Sayonara.